And hello everyone, my name is Nurlisa Arina Binti Anwar. I am from class A4 AS1201 from class 2. And my matrix number is 2020-X61202. I am a student from UiTM Perak Tapah campus. Today, I will explain and present to you how soap being made, what is the process of making soap, and many more. But to make it more simple, it is all about soap. First of all, before we go through the detail of soap, all we need to know is about what is soap, where does it come from. So first, soap is a salt that is formed from the reaction between an alkali and a fatty acid, which is the formula is RCOOH. But usually we use a sodium hydroxide and potassium hydroxide. Wait, not the salt that you are using to make lunch, to make a dinner, of course, but actually that salt, we can use it to make our own homemade soap, you know? Interesting, isn't it? Soap is a sodium salt if the alkali used is sodium hydroxide. But soap also can be formed as a potassium salt if the alkali used is potassium hydroxide. Here in this slide, it shows the general formula of soap where the R is. An alkali group that has long carbon chain, we will write it as capital R, because if we use the real carbon chain, it will become too long and more complicated. So to make it more easier and simple, we will write the formula like this. This is the example of soap. Here we got sodium palmitate, sodium stearate, and also sodium laurate. Okay, now let's proceed with our second subtopic, which is how does soap being prepared? Soap is being prepared by heating vegetable oil with caustic alkali. We can use any type of vegetable oil, which is like a coconut oil or corn oil. Vegetable oil is a natural ester, and the ester comes from the carboxylic acid, and it also can be hydrolyzed by sodium hydroxide into soap. However, the actual process of producing soap is known as saponification. Furthermore, the soap is purified before the dyes and fragrance are added. Next, we proceed with the function of sodium chloride for the soap production. First, concentrated sodium chloride solution is used to precipitate soap. Secondly, it also helps to reduce the solubility of soap. Reaction is represented by the equation below. So this part is actually an ester, which is it also represents as vegetable oils. But at this right side, for the vegetable oil, we only want carboxylic acid. Then it is react to the alkali and produce the soap, or we can call it a salt, which the name written there is sodium palmitate. It comes from the combination of this sodium hydroxide together with this palmitic acid. So for the side result, here we have glycerol. Sodium palmitate has a positive ion. This is a cation, and this is a negative ion part, which is anion. At this part of anion, it has a lot of carbon chain. Sometimes it can go to 12 carbon, 15 carbon, and so on. So just like I said before, the carbon chain will be represented as capital R. So here we write it as RCOONA. Here have the negative part and positive part, but we only want to use the negative part. For the positive part, which is sodium, we will not using it yet, so we will put it aside for a while. This time, at the negative part, here we have another two different parts, which is hydrophilic and hydrophobic. For the hydrophilic part, it loves water, so it will attract to water, while the hydrophobic part it loves dirt, so it will attract it to dirt. So that is the function of an ion or the negative part. If you can see here, this part consists of nonpolar organic part. We call it as a hydrophobic group. And these parts are soluble in greasy surface. Next, the polar group that carries the negative charge. This part is soluble in water and is called hydrophilic group. For the hydrophilic group, it consists of carboxylate group. We will continue with the cleansing action of soap. As you heard before, the hydrophobic part of soap is soluble in grease, while the hydrophilic part soluble in water. So here, soap molecules are located on the boundary between grease and water. This reduces the surface tension of the water, and also it will increase the power of weighting the surface of the fabric by water. Grease can be separated from the fabric. For the highlight, soap actually acts as an agent that wets the fabric. The action of rubbing the fabric is just like you put your clothes in the washing machine or you rub it by your own self, and it also can help you to remove the grease from the fabric surface. And it is cause the grease to break down into droplets, and it is known as emulsification. The reason is there are a repulsive force between grease molecules because each of grease molecule is negatively charged. So soap will act as an emulsifying agent. For the additional information, I am going to show you the advantages and disadvantages of soap. One of the advantages is soap works well for cleaning of clothes with a soft water, but just to make sure that water does not contain calcium 2+ and magnesium 2+. For the disadvantages, it is the opposite way of the advantages I mentioned earlier, which is soap does not work well with the hot water containing calcium 2+ or magnesium 2+. It reacts with calcium 2+ and magnesium 2+ to form a white precipitate which is called scum. Then soap will cause rest. The reaction which takes place is as follows. Alhamdulillah, so that's all for today about soap. My apologies if there are any shortcomings in my presentation for today. I really hope that my presentation for today could help you in future. Thank you for staying and watch my video. Bye, Assalamualaikum, and have a nice day.